Okay, how is it possible? First of all, as I mentioned, you have population growth. It's natural that as the population grows, you'll spend more oil domestically. But this is not the main reason. You cannot use this as an excuse to explain what has happened in Saudi Arabia. There's a much more interesting number called oil consumption per $1,000 of GDP, this is US dollars, of course. The Saudi Arabian number there is horrific. It is much higher than basically any other country in the world. And what is even worse is that it's increasing. In the Western world, ever since the oil shocks in the mid 70s, we have been more and more efficient with our use of oil. Have better cars, more efficient cars, our power plants are becoming more efficient, and so on. Aircrafts are more efficient, of course. Saudi Arabia, on the other hand, has gone the other way. It takes more oil today to produce $1 of GDP than it did 20 years ago. And not many other countries in the world has had that development. Why is that? I believe there's no doubt that the pricing system in Saudi Arabia is the main reason. Take electricity, for instance. Electricity is sold at 0.08 Norwegian kroners per kilowatt to consumers. Industry is about zero point 0.5 Norwegian kroners per kilowatt. I'm sorry that I used Norwegian kroners there for you English speakers. Norwegian kroners historically been around 7 Norwegian kroners to a US dollar. Currently, it is a little bit, the US dollar is a little weaker than what it's been historically. So, what are we talking? We're talking basically 1, 1.2, 1.3 cents per kilowatt hour for consumers. What does this mean? It means people waste a lot of electricity. I've seen people leave their windows open, full blast in the air condition, and going to work in the middle of the summer here when it's 45 degrees outside. They just don't care because the electricity bill is not going to be that high anyhow. Similar story with gas. Natural gas is sold domestically at 0.75 US dollars per million British thermal unit. The world price is something completely different. Say the Henry Hub price recently has been 4 or 5 US dollars, in that range. Petrol is cheap depending on which octane you want. 0.4 to 0.6 SARS per liter. Of course, I come from Norway where gas is very expensive. So I was quite shocked when I got here. Of course, it's expensive. This is cheap by any standards. I remember the first day I was here, me and my colleague went to the Starbucks, which was next to the gas station, and had a full tank of gas and 2 coffees. I remember paying a lot more for the coffees than I did for full tank. Oil, we don't know exactly the price oil is sold to the industry or to utilities. That's why there are estimates. The estimates for when oil is sold as a feedstock to industry is something expected to be like 2 to 5 US dollars per barrel. When I'm talking about as feedstock, I'm talking here about, for instance, the petrochemical industry. Oil sold to utilities to generate electricity, the estimate somewhere between 10 to 20 US dollars per barrel. Both of them are, of course, way off the international price, which is fluctuating around $90 these days, depending on which benchmark you use, and that will, of course, change whenever you listen to it. Check the current global oil price. Whatever it is, I'm guaranteeing is going to be a lot higher than these prices. There is a lot of oil and gas being used or primary energy being used to desalinate water. Water is very rare here in Saudi Arabia. It's not very expensive though, because as everything else, it is heavily subsidized. They use about 7% of that, primary energy for that. Of course, changing these prices, I'm sorry I changed the slide already, but I forgot to tell you, changing these prices is going to be very difficult politically. Cheap energy is a part of or I call it part of the unwritten contract between the ruling royal family and the people. And especially since we're now in a Arab Spring scenario, I just don't see that happening. They really can't change it right now. They might do gradual, slow changes. Well, I don't know. I know, for instance, there's been a debate in Oman about this. But nothing still happened. They still sell gas at 0.77 US dollars per million British thermal units. Personally, I would like to see them use their energy more efficiently through energy economic incentives and so on, which I presume they will start at one point, but it's really not a part of the big debate here. The big debate here is to increase production. By the way, for information, air conditioners are, of course, a very important part of Saudi Arabian energy consumption. It's more expensive, or it takes more energy to to cool a house by 1 degree than it takes to heat it. For instance, us coming from the colder part of the world, we're used to using our energy to heat, not to cool. But it's cheaper to heat than it is to cool. This figure here is very interesting on the slide there. It shows the breakdown of energy, starting with a total production of primary energy, and it shows how it all breaks down to the different sectors and different usage. I'm not going to talk you through every single branch there. I don't have time for that. You can freeze the video and have a closer look to it. What I have done, I have summarized some of the figures in the bottom table, which is they use roughly 32% of primary energy for power production, 23% as feedstocks for industry, and 21% for transport. Feedstocks I'm not going to talk too much about. I don't view that as something bad. It's a way of diversifying their economy, creating jobs, hopefully producing value added. It's good. It's overall not a bad thing for our economy. The big problem is, of course, power generation and transportation. Transportation is also a little hard for them to change themselves. They've developed very much a car driving economy or society. Very little public transport. Of course, I don't expect Saudi Arabia to start inventing the next generation of hybrid cars. I believe that will happen internationally, not domestically. And public transport is sensitive from a cultural issue. There's some religious problems. There'll be a lot of mixing of the sexes and so on. I'm not going to talk too much about it. The one I'm going to focus the most on now is power generation, the by far biggest one. Here are basically listed the alternatives for producing power in the world. First off, I want to mention that for Saudi Arabia, their main problem is peak capacity. Saudi Arabia has, of course, big difference in temperature through the year, and also the use of electricity fluctuates a lot internally during the day. The main problem for Saudi Arabia is that they'll need something about around 40 gigawatts of electric peak capacity within 2030. That is an enormous number, 40 gigawatts. For instance, those of you who are Norwegians, we have talked to you previously about Mongstad. Mongstad, there's a gas power plant which roughly can produce 600 megawatts. That is 0.6 gigawatts. If you talk about the really big gas power plants around the world, coal power plants, it might be a couple of thousand megawatts, or maybe a little bit more as well sometimes. But that's still only 2 gigawatts. I mean, 40 gigawatts is a huge amount of electric peak capacity required. And 2030 is not that far away. Now, quickly I want to explain the difference. What is a gigawatt and what is a gigawatt hour? I know that a lot of people mix these two measurements. Basically, gigawatt, I'm going to use an analogy to driving cars. I'm going to talk about speed and I'm going to talk about total distance. Gigawatt watt means joule per second. It's basically a speed level. It's a per second. It's equivalent to kilometers per hour. Gigawatt is just a number, megawatt, gigawatts, terawatts. On the other hand, when you have the per hour, that is a net length or an amount of energy. It's not per time. So when you say for instance, you read your electricity bill, you'll usually read that you have spent X amount of kilowatt hours. That means X amount of joules or just energy. 1 kilowatt hour is the same as running something that uses a kilowatt electricity, for instance an oven. Run that for 1 hour and you'll have 1 kilowatt hour of electricity. Now, the thing with Saudi Arabia, if you compare for instance with my native Norway, Norway produces most of their power from hydro. We have no capacity problem. We have no problem meeting the peak. Our problem is meeting the year-round production of electricity. We produce roughly 120 terawatt hours. No, we're talking about terawatt hours as the total amount of energy. Saudi Arabia is different. Their main problem is that their peak is so high during the summer, during the middle of the day in the summer, when everybody's using the electricity, they need an enormous amount of electric capacity, which of course during the winter will not basically be used. And In a water power plant or hydropower plant, which Norway has, that's not that important. You open the dam, you close the dam. It's not as important having such a high rate of utilization as you want, for instance, from a gas power plant. You want basically to run your plants at high capacity all year around, or 20, all basically every day, all around. That does never work because electricity has to be consumed there and then. Electricity cannot be stored. Many people believe it can. You might be wondering why. I've heard that. I have a battery in my car. Yes, you do. But large industrial scale quantities of electricity cannot be stored. I went to a Solar Arab conference the other day, and they also talked about this. And even these people who are a little bit tree huggers and they're in the business, they also recognize that you cannot store electricity. The reason why I'm talking about solar energy, that's important for renewables. So moving on, I hope you understand the difference between gigawatts or gigawatts hour.